Hey, this is Mr. Weaver doing topic 1, lesson 3, part 2. And in this one, we're going to use our vocabulary that we talked about in part 1 and move our way into solving linear equations. So after this lesson, you need to be able to create pictorial models, picture models of two-step equations and use it to help you solve for a variable. After this lesson, you'll know you're successful if you can solve your equations using pictorial, or what we're going to call hanger models. So first, let's start off by asking ourselves and defining what is an equation. So your equation, it's a math sentence with an equal sign. It shows that two expressions are equivalent. So remember, expressions did not have an equal sign. An equation does. When we are solving equations, our goal is going to be to figure out what value of the variable makes the whole thing true. We're going to get that by itself. We're going to isolate it using inverse or opposite operations. Okay? All while making sure both sides stay equal to each other. So we're going to use what are called hanger models. Okay, these are our pictorial models because they show us a picture of what's happening in the equation. Here we have a hanger. On one side of the equal sign, we have 2x plus 4. So if we look here, we have 2 x's and we have 4 shown by 4 plus 1s of circles. Okay? The equal sign means that it's balanced. And on the other side, we have 12. So I have 10 and then 2 more. Okay? Right now it is balanced. We have 2x plus 4 on one side. That is equal to, it's balanced with 12. Okay? What happens if we were to take 1 off of the left side? Well, all of a sudden, the right side is going to be heavier because it was balanced. You just took something off of the left, it's lighter. The right side, it's now heavier. It's no longer going to be balanced. So what we need to do is do the same thing to the other side so that everything stays balanced and it will even itself back out. Okay? If I took 1 off of one side and I take 1 off of the other side, well, I just took an equal amount off and now it's still balanced again. When I'm going through this, my goal is going to be to end up with just 1x on one side and then a number on the other, all while making sure this stays balanced. We keep the balance by whatever we do on one side, we do the same thing to the other. I'm going to take away 1 more from the left side. If I do that, what do I need to do? Take away another from the right side. If I take away 1 more from the left again, I still need to take 1 more away from the right. So I had 10 of them, now I only have 9. Take away the last one, and now I'm down to 8. So I took away all 4 of them from the left. So I took away 4 from the right. And now I'm left with just 2 x's on the left and 8 on the right. Now, next what you're going to do, you are going to split up all your x's that are left. Okay. Now, I have 2 x's. I'm going to split them apart because I only want to know how much 1 x is worth. Okay, so I had 2 x's, I split them apart. I'm going to do the same with my number values. So I needed 2 x's. I'm going to divide my number into 2 different parts. I had 8 total, which means each of those parts is going to be 4, still keeping that 8 total. Once it's split apart like this, we can see that an x would balance out to be the same as a 4, which means x equals 4. So if I was solving it, x would be equal to 4. All right, now try one on your own. We had 3x plus 6 equals 9. It is drawn out for you. Hopefully you had a chance to go through and try it on your own, but let's look at how to solve it. So I notice that there's a bunch of 1s on the left and a bunch on the right. There's 4 on the right, so if I get rid of 4 on the left, I can get rid of those 4 on the right. Okay, I can also get rid of 2 more 1s on the left, and if I do that, I need to get rid of 2 more on the right, so I'm down to 3. Split my x's apart. I notice I have 3 groups, so I need to split my 3 into 3 groups. If I do that, each circle would have 1, so my total must be x equals 1. Let's look at a different type of example. If you notice here, there are now 2 red circles. Those represent negative numbers. So here I have 4x minus 2 equals 14. So the negative 2 or the minus 2 is shown by 2 red negative 1s. On one side it's negative, but on the other side it's positive. So if I were to just get rid of a negative 1, well, where do I take away negative 1 from that positive 14? It can't happen. In order to get rid of these negatives, we are going to add the opposite. Okay. Over on the left side of the screen, you can see I put a plus 2. If you see what's happening in the picture, we're going to kind of use that at the same time of solving it without a picture. So why would we add the opposite? Well, a negative 1 and a positive 1 together make 0. So it essentially canceled each other out and disappeared that way. So another strategy, instead of removing what's there, you can add the opposite. But remember, whatever you do to one side, you need to do to the other to keep that balance. So if I added 2 to the left side, I need to add 2 to the right side. So in the equation, we added 2. I combined everything together. I have 4 x's now, and I have 16. Now I'm back to where we were before. So I'm going to need to divide it by 4, which means that I split it apart. Splitting it apart, I had 4 x's, split them apart. 16 split into 4 groups makes each group equal to 4. Okay. Try the one on your own. I'm not going to go through that one, but see how well you can do. Let's look at a third example. Here we have a little bit more complicated of a problem. Okay, I have negative 2x minus 2 plus x plus 11 equals 17. So on one side of the hanger, I have my negative 2x's. I drew them separately. I have a minus 2, a positive x, and positive 11. And then on the right side, I have positive 17. Here's our first instance where we're going to want to combine like terms. So combining like terms means we're getting everything that is the same together. So I have negative 2 here. I have positive 11 here. They are both constants, meaning they're the same kind of term. So if I combine them together, if I had negative 2 plus 11, okay, combine those together, I would end up with positive 9. Okay, I just showed as combined as one picture. Bring everything else down. Now we can do what we have been doing, and if we have 9 on the left side, we can take that away, and if we take away 9 from the left, we must take away 9 from the right, which will leave us with positive 8 on the right. Next, let's look at the x's. We have 2 negative x's and a positive x. we should combine these together like we did with the constants. They are like terms, they have the same variable of x and no exponent. So I'm going to put a positive x with a negative x. Well, if you remember what we just did a few minutes ago with a positive 1 and a negative 1, they cancel each other out. They make 0. So those two just canceled each other out and now they disappeared. Okay, when I do that, all I'm left with is negative x equals positive 8. Now, it looks like we might be done, but we're not quite. We need to end up and figure out what positive x equals. In order to get it to a positive x, I'm going to divide by negative 1. So I pulled that negative 1 out. Okay, a negative divided by a negative will give you a positive. And whatever I do to one side, I do to the other. And what I end up with is positive x and negative 8. So if you notice, I went from a negative x and a positive 8 to a positive x and a negative 8. All it did was switch signs. Okay, so if you come across an instance where you have a negative x at the end, switch the signs. So switch it to positive, and then whatever the sign was of your number, switch that to the opposite. Okay, all right, try your example, see how you can do it. All right, last example on here. We have an even more complicated problem. I have 2x plus 4 plus another x minus 12 on the left side, and I have 11 plus 2x plus 3 on the right. Don't panic on this kind of problem. Combine like terms and use what you know about getting rid of things from one side. So I'm going to start with my numbers on the left. I had positive 4 and negative 12. Combine those together, and I end up with negative 8. Now I'm going to do the same thing with my numbers on the right side. Okay, positive 11 and positive 3. Combine those two together, and I end up with positive 14. I just combined my constants on one side and combined my constants on the other, and now I'm only left with one of them on the left and one on the right. Okay? To get rid of that negative 8, I'm going to do the opposite, add the opposite, so positive 8, and then whatever I do to one side, do to the other, and I end up with positive 22. Next, let's deal with our x's. Just like our numbers, if you want to remove an x or a variable, there are two ways. You can simply take one off of one side and then take it off of the other, or you could add the opposite to one side and add the opposite to the other. So I notice that I have the same thing on both sides. I have a positive x here and a positive x here. So if I take away a positive x from the left side, I can just take away a positive x from the right side. I can do the same thing again. Take away another positive x and another positive x from both sides. Now, after just that, I am left with x and 22, and everything is still balanced. So, removing two x's from both sides left me with x is 22. There's our answer. X is 22. So, to recap what happened in this lesson, combine like terms, okay? Then start taking stuff off of one side and do it the same thing to the other. You can do it by adding the opposite, or if they're the same, take one off from one side and one off from the other. In lesson 3, part 2, We learned what a hanger diagram was and how that it's a pictorial model showing how two expressions in an equation help keep their balance. Okay? If you did something to one side from that hanger diagram, you had to do the same thing to the other in order for you to keep it balanced. You can remove something from those hangers in two different ways. So you can remove the same amount from both sides, right? If we had a +1 on one side and a +1 on the other, we could just take them away. Or you could add the opposite to both sides. If we had that -1, we could add a +1 to both sides, and that would help cancel out by making 0. Once we removed everything that we could from both sides, we should have been left with a variable on one side and a constant on the other. Once there's only variables on one side and constants on the other, then we just split the variables and then split the constants equally amongst how many variables there were. That will help us determine how much each variable was worth. So after this lesson, do you know how to solve equations with your hanger diagrams? And do you know how to solve those hanger diagrams with variables on both sides? Okay? Both sides of the equal sign, like we did in that last problem. If you're not confident with these two things, you probably should go back and watch parts of this video again to help deepen your understanding. And that's it. That's all there is for Lesson 3, Part 2.